since angle C is a right angle, we could then say the measure of angle C is 90 degrees. We can make the conclusion because the hypothesis came true. Let's look at letter D. All giraffes are tall animals. So we could say our hypothesis is that we're starting with a giraffe. If an animal is a giraffe, right? Yesterday we spent some time rewriting statements in if-then form. So if an animal is a giraffe, then what? Well, then it's tall. So our conclusion is that if something is a giraffe, then we can say it's tall. So then we look at the specific statement. Then it says, okay, well, Stretch is a tall animal. Well, did our hypothesis come true? Is Stretch, did it say that Stretch is a giraffe? No, it said Stretch is tall. So can we confidently say, well, just because Stretch is tall, he's definitely a giraffe? Well, not necessarily. There are other tall animals. Elephants are tall, right? We could have other tall animals here. So here, the tall animal, remember, was the conclusion in the original sentence. And so when the conclusions match, we actually can't make a conclusion, as funny as that is. No conclusion. We needed the hypotheses to match in order to make a conclusion. All right, so again, no conclusion, and our reason is that Stretch could be an elephant. So that's kind of like a counterexample to show why we couldn't make that conclusion. All right, next one. It says no elementary school student is old enough to vote. So this is the rule. This is what we're going off of. So our hypothesis, maybe if a student is an elementary student, then can they vote? Then they're not old enough to vote, right? So bring that no over here. Okay, that makes sense. No elementary school student is old enough to vote. Cool. All right, so let's see what's going on with our specific example. It says Kendrick is old enough to vote. Kendrick is old enough to vote. So can we make a conclusion here? Well, the statement that we started with, no elementary school student is old enough to vote. Or if you're an elementary school student, then you're not old enough to vote. So if this says he is old enough to vote, can we make a conclusion? So notice in the sentence, in the first sentence, we had this word no or not, which kind of makes it a little bit different. So we have a little bit of movement here, because here then it says he is old enough to vote. So logic would tell us if he is old enough to vote, then we can say, well, then Kendrick must not be an elementary school student. Kendrick is not an elementary school student. So that one was a little bit trickier, but also kind of common sense, hopefully. And letter F says, no mathematicians are boring. Kenji is a mathematician. So based off the sentence, no mathematicians are boring, and if Kenji's a mathematician, well then Kenji is not boring. So we can make the conclusion here. So again, the key, now these last couple ones were kind of tricky, but these ones in the middle, specifically, I would star B and, let's see, B and A, or A or C. Looking at these two, so A, B, C, D, so the two that are no conclusion, make sure you see that the hypothesis has to come true, right? If the hypothesis isn't coming true in the specific example, then you cannot make a conclusion. If it is coming true, like in letter A, then yes, you can make a conclusion. So these are some really important types of questions that you'll definitely see on your quiz on Tuesday. So make sure you go back and understand. If you don't, if you're a little bit confused, then I will be back on Monday and I'll be happy to go over any of these. Okay. All right, so last part is this chain rule, the law of syllogism. So this word here is pronounced syllogism, not syllogism, or it's hard. I know it looks kind of hard to say, but it's syllogism. And an easier way to say it is we're just following the chain rule. And so basically, the chain rule says, kind of like dominoes, if we link up our statements, so I'll bring us back to dominoes here. Let's say if we have 1 and then 2 and then 2 here, and then we'll go to 4, we can keep linking up here. So because these are linked up, the chain rule says, let's pretend instead of these are being numbers, let's say they're statements. So let's say P implies Q. So then the next domino would have to start with Q. And let's say that statement implies R. And then the next domino would have to start with R. And that would imply, let's say, S. We could keep going and going and going. The law of syllogism says that if we can line up all of our statements where they repeat and match up, then we can say the first statement implies the last statement. And so you can see it like the dominoes. You can see it in this middle column here. It says, if P is true, then Q is true. And then if it matches up here, if Q is true, then R is true. What we can say then is that if those two match up in the middle here, we can kind of skip those all together and say P implies R, right? And we can say this is our final conclusion, then P implies R. So put some words to it. If Chanel is in 12th grade, then she's a senior. So 12th grade, then she's a senior. Notice the next sentence starts with she's a senior. So it matches up here, right? And if those two match up, we can kind of skip them and end with she's in calculus. So because these two match up, the final conclusion we can come up with is this sentence, that if Chanel's in 12th grade, then she's in calculus class. So we can match up the statements in order, kind of like dominoes, and once we do that, the law of syllogism says we can say the first implies the last. Okay, and we're going to see some examples there in a second. But one last thing to note is if you have a conditional statement, P implies Q, then the contrapositive is also true. Now, the contrapositive is taking the P and the Q, flipping their order, so putting the Q first and then the P second, and negating them. Negating them means putting the word not in front of it, kind of doing the opposite. And the way we notate that is with this little tilde, that little squiggly line. That gives us the contrapositive. And the contrapositive has the same truth value as the conditional, meaning if the conditional statement is true, then the contrapositive is true. Okay, keep that in the back burner. We'll bring it up in a second. So let's try an example of how we're going to use this chain rule and this law of syllogism. So it says, assume the following statements are true. Use the chain rule to write another true statement. So this letter A says, if it's raining, the sky is cloudy. If the sky is cloudy, then you can't see the sun. So what I like to do is look at the different phrases. It is raining. So that's a phrase. I'm going to give it a name. I'll call it P. The next phrase I see is then the sky is cloudy. I'll call that Q. In the next sentence, I see that same phrase, the sky is cloudy. It's repeated. So that's the same Q statement. So notice P implies Q. And then in the next sentence, we start with Q. So these are matching up. It says, if the sky is cloudy, then you can't see the sun. So I'll give that another letter, R. So then Q implies R. So if you think about it like dominoes, our dominoes are kind of matched up here, right? In the middle here, we see the Q's matching up. So I'll go like this. Since the Q's match up, we can kind of skip over them and say P implies R. The first implies the last. So we can skip over the middle statements and just say the first statement implies the last statement. That's what the law of syllogism says we can do. So since we know kind of the order now, let's write it out with the words. So if, remember, P's statement was it is raining. So if it is raining, then now let's go to our statement. So our statement is you can't see the sun. Can't see the sun. And this is another true statement that we can make by using the law of syllogism. All right, so you'll see some questions with some sentences, things that you can read, but then you're going to see some examples where we're just giving you the letters of the statements. So that's what we're seeing here in letter B. So what I do first, with the law of syllogism, it's all about matching, right? Everyone should have a pair, like when you're lining up the dominoes. So what I do first is I look at all these letters and see which letters are written only one time. So right off the bat, I see that A is only written once. So I'm going to rewrite that statement. A implies B. And now I'm going to start my train, my law of syllogism, down this line. So if A implies B, my next statement should start with B. So I look down this line and I see, oh, B implies E. So that'll be my next one. I'm just going to cross it off once I've written it. So now my next statement should start with E. So I look, oh, E implies C. So that one's next. Since I ended with C, my next one should start with C, and C implies D. So far, so good. They're all repeating. A to B, B to E, E to C, C to D. So my next statement should start with D, right? Well, when I look back here, is the last statement here, does it start with D? No. So now what? Well, that's where we're going to call upon this contrapositive. That the contrapositive is going to have the same truth value as the conditional statement. So if we can rewrite the original as the contrapositive, they're both going to be true. So that's what we can do here. We can rewrite this by flipping the order and negating them. Well, negating a negation just undoes it, right? So we're going to take the negation away and we're going to flip the order. So D is going to go first and then F's going to go last. So we have the statement then D implies F. So again, we use the contrapositive here. And now since all of these are lined up, since they're all matching, we kind of have a train, right? Now we can say that the first implies the last. So our answer is that A implies F. We can go through all that work to finally say, all right, A implies F. Okay, so